Hello students, welcome to our channel H Mathematics. I hope you are all well. Matrix Part 2, Types of Matrix. First, definition of rectangular matrix. A matrix in which number of rows and columns are not equal is called a rectangular matrix. A matrix in which number of rows and columns are not equal is called a rectangular matrix. For example, a matrix 251 341 is a rectangular matrix of order 2 by 3. Here number of rows is 2 and column 3. Second type of matrix, definition of square matrix. A matrix in which the number of rows is equal to the number of columns is called square matrix. A matrix in which the number of rows is equal to the number of columns is called square matrix. For example, take a matrix 215 324 336 is a square matrix of order 3 by 3. Here number of rows 1 2 3 is equals to the number of columns 1 2 3. Three types of matrix, definition of diagonal matrix. A square matrix whose all elements except those on the principal diagonal are 0 is called diagonal matrix. A square matrix whose all elements except on those on the line principal diagonal are 0 is called diagonal matrix. A matrix A square matrix whose all elements except those on the principal diagonal are 0 is called a diagonal matrix. For example, a matrix 1 0 0 0 3 0 0 0 2 is a diagonal matrix of order 3 by 3. Here matrix A is square matrix because number of rows 1 2 3 is equals to number of columns 1 2 3, and also all elements except those on the principal diagonal. Here it is principal diagonal 1 3 2 are diagonal elements are 0. Types of matrix. Fourth type of matrix, definition of square matrix. A square matrix whose all elements except those on the principal diagonal are 0 and principal diagonal elements are equal is called scalar matrix. Types of matrix. Fourth definition of scalar matrix. A square matrix whose all elements except those on the principal diagonal are 0 and all principal diagonal elements are equal is called scalar matrix. For example, matrix A 2 0 0 0 2 0 0 0 2 is a scalar matrix of order 3 by 3. Here matrix A is a square matrix. Number of rows 1 2 3 is equals to the number of columns 1 2 3, and all elements except those on the principal diagonal are 0 2 0 0 0 2 0 0 0 2. All principal diagonals elements 2 2 2 are equal. So matrix A is a scalar matrix. Types of matrix. Fifth, definition of identity or unit matrix. A square matrix whose principal diagonal elements are all unity and others elements are all zero is called an identity or unit matrix. A square matrix whose principal diagonal elements are all unity and other elements are all zero is called an identity or unit matrix. For example, 1 0 0 0 1 0 0 0 1 is an identity matrix or unit matrix of order 3 by 3. Here given matrix, a square matrix, elements are all unity 1 1 1 in principal diagonal, and it's denoted by I3 because order of the square matrix 3 by 3. If order of the matrix 4 by 4, then identity or unit matrix is denoted by I4. Similarly, for n by n matrix, it's denoted by In. Null or zero matrix. Types of matrix. Sixth, null or zero matrix. Definition of null of zero. Null or zero matrix. Types of matrix. Sixth, null or zero matrix. A square matrix of any order, rectangular or square, whose all elements are zero is called a null matrix or zero matrix, and it is denoted by capital O. For example, 0 0 0 0 and 0 0 0 0 0 0. 2 by 3 matrix. Here it is 2 by 2 matrix. Rectangular or square, a matrix of any order, rectangular or square, whose all elements are zero is called null or zero matrix. Here it is square matrix whose all elements are zero, and it is rectangular matrix whose all elements are zero. Types of matrix. Seventh, definition of row matrix. A matrix having only one row and and any number of columns is called a Row matrix. A matrix having only one row and any number of columns is called a row matrix. For example, a 1 2 3 is a row matrix of order 1 by 3, because here only one row or 1 2 3 are number of columns. By definition, is a row matrix of order 1 by 3. Eight types of matrix. Definition of column matrix. A matrix having only one column and any number of rows is called a scalar column matrix. A matrix having only one column and any number of rows is called a column matrix. For example, A1 to 3 is a column matrix of order 3 by 1, because here only one column 1 to 3 and number of rows 1 to 3 1 to 3. So by definition of column matrix, it is a example of column matrix of order 3 by 1. Ninth types of matrix. Definition of upper triangular or lower triangular matrix. A square matrix is called an upper triangular matrix if all the elements below the principal diagonal are 0, and it is said to be lower triangular matrix if all the elements above the principal diagonal are 0. A square matrix is called an upper triangular matrix if all the elements below the principal diagonal are 0, and it's said to be lower triangular matrix if all the elements above the principal diagonal are 0. For example, if we take matrix 2 3 3 0 5 4 0 0 8 is an upper triangular matrix because all elements below the principal diagonal are 0. Here it is 0 5 4 0 0 8 2 3 3. And lower triangular matrix B0 2 0 0 4 5 0 3 3 8 is an lower triangular matrix because all elements above the principal diagonal are 0. 2 0 0 4 5 0 3 3 8 0 0 0. 10th types of matrix. Definition of submatrix. A matrix obtained by deleting some rows or column or both of a given matrix is called its submatrix. A matrix obtained by deleting some rows or columns or both of a given matrix is called its submatrix. If we take a matrix 4 5 5 2 of order 2 by 2 is a submatrix of a matrix of order 3 by 3 4 5 6 3 3 6 5 2 1, because matrix 4 5 5 2 of order 2 by 2 is obtained by deleting third column and second row. Properties of Matrix multiplication. Properties of matrix multiplications. 1. In general, matrix multiplication is not commutative, that's AB not equals to BA for all AB. Second, matrix multiplication is associative, that is ABC 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 is equal to ABC, where A, B, C are three matrices of dimension m by n, n by p, p by q respectively. 3. Matrix multiplication is distributive, that is A B plus C is equal to AB plus AC, where A, B, C are any three matrices of dimension m by n, n by p and p by q respectively. Transpose of a matrix. The transpose of a matrix A is obtained by interchanging its rows and columns, and it is denoted by AT or A dash. Transpose of a matrix. The transpose of a matrix A is denoted by interchanging its rows and columns, and it's denoted by it A dash or AT. For example, a matrix 152 0 1 3, then 80 1 0 5 1 2 3. Here interchanging its row and columns. Some rules of transpose of a matrix. 1. A transpose to the power transpose is equals to A. Number 2. A plus B transpose equals to A transpose plus B transpose. Number 3. AB to the power transpose equals to B transpose A transpose. Mean AB transpose. A transpose whole transpose is equals to A transpose. Second, A plus B transpose is equals to A transpose plus B transpose. AB transpose is equals to B transpose A transpose. Symmetric matrix. A square matrix is said to be a symmetric matrix if the transpose of A is equals to A, that is A transpose equals to A. A square matrix is said to be a symmetric matrix if the transpose of A is equals to A, that is A transpose equals to A. For example, A 1 5 4 5 2 7 4 7 5 3 by 3 matrix. If we take transpose, then we get matrix A. Skew symmetric matrix. A square matrix A is said to be skew symmetric if A transpose equals to minus A. For example, if we take a matrix 0 3 5 3 0 4 5 4 0 3 by 3 matrix, here A transpose equals to A minus A, so given matrix A skew symmetric matrix. If we take odd example, then you see that matrix A is equals to 0 1 2 1 2 0 4 4 0. Then A transpose equals to minus here minus 4 minus 1 minus 2 minus 4. A transpose is equals to 0 minus 1 minus 2 1 2 0 minus 4 4 0 is equals to minus A. If we take minus 1, then we get 0 1 2 minus 1 minus 2 0 minus 4 4 0. So is equals to minus A, and it is also example for skew symmetric matrix.